Yes.
Good evening, everyone. You're watching the late night show's Neuroscience Special. I'm your host, Riley Brzozowski. A group of students were really interested in their recent Action Potential Lab and decided to look into it further and document their progress. To start out, they used a spiker box. A spiker box is a relatively inexpensive tool that was developed in 2012 for primary use in middle and high school neuroscience classes. It is a bioamplifier for electrical signals, which means that it just increases the signal of different physiological electrical activity in the body. They used this on living cockroaches. Cockroaches are a great study organism for this project because they have really large action potentials that can be picked up by the spiker box. Cockroaches have spines on their tibia and femur, and each spine has a nerve wrapped around it. This means that touching the spine should produce action potentials. Specifically, they wanted to see what would happen if they added caffeine. Caffeine is a stimulant, which implies an increase in activity in the body. Caffeine specifically does this through inhibiting adenosine receptors. Adenosine receptors will drive drowsiness, so when they're inhibited, it will prevent drowsiness. They dropped caffeine on their cockroach's leg to see what would happen, and the average action potential length decreased from 0.75 seconds to 0.5 seconds. The action potential amplitude was also drastically lowered from its control value of 1.8 units to 0.5 units. The recorded effect that the caffeine had on the leg aligns with the fact that caffeine inhibits adenosine receptors. And now moving on to our special guest of the night, Kevin Warwick. Everybody give it up for Kevin Warwick. Unfortunately, he couldn't be with us tonight, but I have his bio for you right here. Kevin Warwick is a British engineer studying the interfaces between computers and the human body, which is related to the previously mentioned lab on cockroaches and the modeling of physioelectric activity in the body. Warwick is a little wild to believe that humans need to improve on themselves with technology so they don't get taken over by machines. Specifically, he has said, "There's no way I want to stay a mere human." Deep. Warwick is also working with Parkinson's, where he designed an implant that would execute deep brain stimulation precisely when it is needed. Now Warwick is working on Project Cyborg, which is essentially an effort to turn himself into a cyborg through cybernetic organism implantations in his arm, consisting of both organic and biomechatronic parts. Biomechatronic means it's relating to biology, mechanics, and electronics. Warwick just wishes he were a machine. Alright, thanks for joining me tonight, folks. This is the late night show, and I'm your host, Riley Brzozowski, signing off.